The given set is a basis for a subspace W. So these two vectors form a basis for W. Use the Gram-Schmidt process to produce an orthogonal basis. This is a basis but not orthogonal because if we multiply these two vectors, that means if we take inner product or dot product, then the product is not zero. But using Gram-Schmidt process, we can create an orthogonal basis. Okay, and for orthogonal basis, we denote by u1. Let's say u1, u2. We were given x1, x2. So the first vector u1 in this basis is the same as previous, x1 itself, 0, 4, 2. Now we want to find second vector u2. That will be, if you look at this picture, pretty much just the idea. This is not exact related to this these vectors, but this is the idea. So we have x1 first vector here and x2. They are not perpendicular to each other. Now we want to find a vector perpendicular to x1, so this vector pretty much. So we find the projection of x2 onto u1 or x1 first vector. That's the projection vector, and it will be always in this direction, this one up to here, given by this formula. Then we subtract this projection from this x2. When we subtract projection from x2, so we have these three vectors pretty much, and this is going this way plus this way is this, but if we subtract this from this, we get this. So this projection, this is scalar number. For this question, this one is same as u1. We can calculate, just find the dot product of x2 with u1, multiply, we get this. u1 dot u1 multiply u1 with itself, we get this. So 1/2 of u1. So this number is 1/2. u1 is first vector, which is 0, 4, 2. Now 1/2 of 0, 4, 2 means 1/2 times 0, 1/2 times 4, 1/2 times 2, and we're gonna get the vector. So 1/2 times 0 is just 0, 5 minus 0 is 5, 6 minus 1/2 of 4, 1/2 of 4 is 2, 6 minus 2 is 4, 1/2 of 2 is 1, -7 minus 1, -8. So u1 and u2 forms an orthogonal basis. You can check if we multiply these two vectors u1 and u2, the inner product or dot product is 0. So u1 u2 is the answer.